Assalamualaikum to our dear lecturer, Dr. Al-Farizani Binti Bahaudin. We are from Group 4 and today we would like to present about our PBL project analog communication. Before we start our presentation, we would like to introduce ourselves. My name is Muhammad Nazwan Nafid bin Muhammad Nizam, CE210183, and other four members, Ahmad Daniel, Fifi Rahimi, Daniel Ashraf, and Muhammad Ifan.
Hello, my name is Daniel Ashraf bin Sarwar Anwar. I will present our AM transmitter about the circuit design and description. Our circuit contains the audio amplifier, amplitude modulator, and RF power amplifier. Our concept is when the audio jack receive the signal, I mean when the audio jack receive the sound, and the audio jack will convert the sound into the electrical signal, and the sound will be transmit into the sound will be transmit to the receiver by using the antenna at the transmitter. So the circuit of AM transmitter consists of inductor and capacitor, also known as the tank circuit, to determine the frequency of the AM circuit. So this can be called as tune frequency. Next, audio jacks in the circuit act as input of the AM transmitter, detect the sound and transmit into the electrical signal. The transistor in this AM circuit is boosting, modulating, and amplifying the signal for the effective radio wave transmission. They are effective of transmit the electrical signal to the receiver. The antenna will be the output of this AM transmitter and transmit to the signal receiver. To get the perfect sound, the receiver need to be tuned until the receiver receive the clear information signal. So that's all from me. Thank you.
Hello, my name is Maifan bin Salim. So I will present to you on the input analysis part. So for the first one, analyze the input waveform from the audio jack early in the AM amplitude modulation radio system project. Then examine the audio signal from music players for its frequency range, amplitude, and overall quality. Then address the chosen modulation method, whether it is double sideband or single sideband, with a focus on modulation index. Then consider essential aspect of the carrier signal, including frequency, amplitude, and stability, ensuring compliance with regulation. Then the last one is emphasize the importance of linear modulator circuit designed to prevent distortion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Daniel bin Abdul Aziz. Today, I would like to present to you about output subsystem from our circuit. Okay, before I start, I would like to explain to you what is subsystem. A subsystem is a component of a larger system that performs a specific function or set of functions. It is essentially a smaller system within a bigger one, working together to achieve a more complex objective. For example, in a car, the engine, transmission, brakes, and electrical system are all subsystems that work together to make the car run. Okay, for our circuit, they have six output subsystem. The first one is transistor, Q2. The last stage of amplification is this transistor. It amplifies the oscillators, modulate signal to a level where the antenna can transmit it effectively. For the transistor to function well and sustain the power level necessary for transmission without distortion, the biasing must be set appropriately. The second one is inductor N1. The inductor, which is a component of the tank circuit, and C4, capacitor 4, are essential in determining the carrier wave frequency. It also contributes to the impedance matching between the transistor and the antenna in the output stage. Next, capacitor C4 and C5. A component of the matching and tuning network are these capacitors. L1 and C4 works together to determine the oscillator's frequency. Most likely, C5 is coupling capacitor that only permit the AC modulate signal to get through while preventing DC from getting to the antenna. Additionally, it collaborates with L1 to match the antenna's impedance to the rest of the circuits, a necessary step for effective energy transfer. Next, the resistor R5. This resistor and the others in circuits assist in stabilizing the amplifier's performance and determining Q2's operating point. In order to keep Q2 collector from overheating or burning out, it might also be used to limit the current flowing through it. Next, the antenna. The actual part that emit the energy as an electromagnetic wave into the atmosphere is the antenna. Antenna length and design are important factors that are usually selected according to the carrier frequency wavelength. The antenna is typically a quarter wavelength or multiple of its effective transmission. Last but not least, RF emission. The signal is transmitted to the antenna after it has been amplified and passed via the coupling capacitor C5. The electrical signal is then modified by the antenna and transformed into RF radio frequency signal that may travel through the atmosphere.
For the output analysis, the first one we would like to talk about is waveform analysis. The oscillator in an AM transmitter ideally produces a sinusoidal waveform through resonate in the AC and circuit inductor and capacitor, ensuring a clean and well-defined carrier signal. For theoretical, for real value observation, the ideal sinusoidal waveform due to imperfection in component, nonlinearities, or external influence. Oscillator measure variable distortion or irregularities in the waveform. For instance, actual value might divide slightly from the expected sinusoidal shape, showcasing the impact of real world factor on waveform fidelity. For frequency analysis, from theoretical, the oscillator theoretical frequency in AM transmitter is calculated using the formula, ensuring alignment with the intended carrier frequency based on specific value for inductor and capacitor. For real value observation, practical measurement of the oscillator frequency may show slightly variation from the theoretical value due to manufacturing tolerance, temperature effect, and other factors. Verification using more precise instruments such as frequency counter or spectrum analyzer become essential to confirm the real frequency and ensure it meets the design specification. For the next output analysis is frequency spectrum. Okay, for frequency spectrum, for carrier frequency and sideband, carrier frequency is 947 kHz. For upper sideband is 947.49 kHz. For lower sideband is 946.51 kHz. You see a centimetric flanking of the sideband is encapsulate modulated information. Bandwidth and modulation frequency. For bandwidth, calculate as twice the highest modulating audio frequency. Total bandwidth of the AM signal is 980 kHz. For maximum modulation frequency, FM, is 490 Hz. Okay, for discussion, there are several areas for this project analog communication. The first one is frequency instability. The challenging part is predicting carrier frequency due to temperature change or component tolerance impact, unstable transmission quality, solution, pre- precise component selection, carefully calibration, and temperature compensation. The second one is harmonic distortion. Challenge nonlinear behavior causing harmonic distortion in transistor. Impact unwanted multiple of transmission frequency, risking interference. Solution: mitigate distortion through linear operation, proper biasing, and meticulous circuit design. The third one is modulation drift problem. Channel lacking or excessive modulation affecting signal accuracy is a challenge. Impact possible interference due to weak transmission or distortion. Solution: pay close attention to modulation circuit design, biasing level, and optimize signal strengths. And the last one is addressing accuracy concern through through review. Exam circuit design truly focusing on stability, modulation depth, and biasing level. Testing using string testing and calibration procedure. And the last one is consider the following external factor. Consider the environment and potential source of interference.
Assalamualaikum. My name is Muhammad Fikri bin Rahimi and my medical number is CE210207. So today I'm going to present conclusion. First one, key role in radio communication. The AM transmitter plays a vital role in radio communication by facilitating the broadcast of diverse content to a wide audience. It achieves this by modulating carrier signals, allowing the transmission of audio signal for radio station. And then second, support for varied content. Each modulation capability enables radio station to broadcast a variety of content, including music, news, and entertainment. This flexibility makes AM transmitter essential tool for delivery of broad range of information to the public. Okay, third, enduring relevance. Despite facing competition from newer modulation techniques, AM transmitters remain relevant due to their simplicity and cost effectiveness. This makes them a practical choice for certain applications, contributing to their enduring presence in the field of wireless communication. Okay, for technological ongoing technological advancement have led to improvement in efficiency and signal quality for AM transmitter. This enhancement ensure a more reliable and higher quality transmission experience for both broadcaster and listener. Okay, the last one is historical significance. The historical significance of AM transmitter dating back to the early days of radio highlight their enduring importance. This longevity is a testament to their foundational role in connecting people through the airways, supporting various communication needs, from local broadcast to emergency communication. Thank you.
To prove our project is successful, we need to compete in AM radio transmitter competition with other sections by faculty, electrical and electronic. From the result, we are in the third place in this competition with result above 2.5 meter with this level. That's a good proof for us that our project is successful in the analog communication. That's all from us. Thank you very much.